Okay, had a couple of requests for the simultaneous equation question that I've asked for as evidence. This is one that we're going to have to do using substitution. So the first thing I'm going to do is change equation number 2 so that we've got x equals, and so I'm just going to move that minus 2y over to the side, add 2y, and now I've got this, and I can substitute this into my first equation. So x is now 2y minus 3, so I've got open brackets 2y minus 3 squared plus y squared equals 18. I'm going to expand this out and simplify, adding that extra y squared there. 2y squared is 4y squared. I've got to do 2y times minus 3 twice, so I'm going to have minus 12y. I've got minus 3 times itself is going to be positive 9, and then I've still got that my y squared there. That equals 18. Then I'm going to add these things up and move the 18 over here, so 4y plus y squared is 5y squared minus 12y, and then when I move this over I get minus 9 equals 0. Now this is a bit more manageable. You could use the quadratic formula, but it's actually not too much of a ask to do the factorization, because we've got 5y and y, because 5 is prime, it can only be these two. And then I've got two options for 9 and 1, or 3 and 3. And considering that the difference is only minus 12 when I multiply out, I'm pretty sure we're going to have to use 3 and 3. So when I've got 3 and 3, I then think about the signs. I can only make minus 9 by having a positive and a negative, but I've also got to consider the difference. So if I think back and I go 5y multiplied by negative 3, that's going to give me minus 15, add the 3y, y times its 3 over here, and that's going to be positive. So now I can solve for y. There's two solutions, obviously. I've got y equals 3. Obviously 3 minus 3 is 0, 0 times anything is 0. And then if I think of this equal to 0, 5y add 3 equals 0. Move that over, I get minus 3 and divide by 5, so I'm going to have y equals minus 3 fifths, which is negative 0.6. So we've got two solutions. We're going to have to try them both and get both x values out for all marks. I'm also going to substitute it into number 2 because I don't have to square anything, it'd be much easier. So I'm going to put y equals 3 first. I'm going to use this part of the equation because it's already got x. There's the subject, 2 lots of 3 minus 3. So one solution is x equals 3, and the other solution y equals 0.6. Oops, sorry, no, negative 0.6. Sorry, the writing's going a bit off. So we've got x equals 2 lots of negative 0.6 minus 3. And when I double that, I just get x equals minus 1.2 minus 3, and x equals negative 4.2. So I've got two solutions. When y is 3, x is also 3, and the other solution when x is minus 4.2, y is minus 0.6.